Today we're going to go back to the same data sets that we were using previously when we were talking about regressions, but we're going to learn another key feature of the graphing calculator, and that has to do with something called the correlation coefficient. So go ahead and highlight that on your worksheet. Okay, this thing called the correlation coefficient. You have to turn that on, that feature on your calculator. So at this point, grab your calculator and let me show you how to turn that feature on. Okay, so you'll notice down by the number 0, it says catalog right above that. And so we're going to access that, so go ahead and hit the second button and then catalog, and you're going to get this list of all the features in the calculator. What we want to do is come straight down and just arrow down through the alphabetical order, all the A's, the B's, the C's, and when you get to D's, kind of slow down and you want to find the one that says diagnostic and make sure you pick on, not off. So we want to turn this diagnostic feature on. So hit enter and then one more time and it should say done. Okay, and that will turn that feature on so that everybody is using that feature on the calculator. All right, thank you. Okay. Now at this point, I'm going to want you to use your calculator and put this data back in, the same data that we were using yesterday. So our X lists, which are going to be the lists that are coming, that are coming across here as 1 through 8. So put that into your L1, and your Y values should go into L2. So we can work on that together. Okay, stat, edit. Okay, I still have those values put in from the day before, so my list 1 through 8, and my L2, the 4.5 value through the end. And if you have to pause the recording to get everybody caught up, go ahead and do that. You'll also need to reset the windows. If you'll remember from yesterday, we talked about how to select our windows because 0 is the minimum of the X, so we want to round that down to 0. 8 is the maximum for the X, we want to round that up to 10, and that gives me a scale of 1. If you remember how to get that, that's 10 minus 0 divided by 10. That turns out to be 1. Okay, for the Y values, we're going for 4.5, and we want to round that down, so we're going to round that to 0. And 20.5, we round that up, so we round that to 30, and then we figure out our scale, 30 minus 0 over 10, so that turns out to be a scale of 3. So make sure that you set your window to be a scale of 3. So let's take a look at that. Hit our window feature, 0 to 10 with a scale of 1, followed by 0 to 30. With a scale of 3. And if you jump right now and hit graph, you probably won't see anything. Let's try that. Okay, if I hit graph, I just have a blank screen. Don't forget, you can't just jump to graph. You have to go to stat plot, which is second y equals, and make sure that your plot is on. Okay, you could do that two ways. You could do that from here, select number 1 and turn it on. That would be one way. You could also go to your y equals button and make sure it's highlighted there. Once you have that turned on, now you should see the nice linear. And we talked about this being a positive and a very strong correlation for this graph. Okay, so go ahead and on your worksheet, you're going to fill in that this has a positive correlation, and you can even add the fact that it is strong. The strength is in the straightness of the line. Okay, now we're to the point where we're going to learn something new. Yesterday, we calculated the slope by hand, and we took the first point and the last point and we found the slope. This time we're going to have the calculator find us the slope itself. All right, and so we're going to use the stat calc feature. And so not only are we going to go to stat edit, but we're going to go over to stat calc for the first time. Okay, so using my stat button, I'm going to go over to the edit feature. So I'm going to over to the calc menu, which is one menu over. And because it looks like a line, we are going to pick option number 4, which is the lin reg option. Okay, we'll go ahead and select that. Now some of you might have calculators that look like this, and others of you might have older calculators that look a little bit different. I'll show you both in just a minute. By default, your calculator should be set up to do L1 and L2, which is where our data is. If for some reason you have to change that, remember that your L1 is here by number 1 and your L2 is by number 2. What your job is to enter this regression equation. Don't skip that step. Okay, your job is to tell it where to put it. Now I want to show you what we've got right now. Right now, our y equals has a plot on, but the rest of the y equals is totally blank. By using the regression properly, we'll be able to fill that in, have the calculator do all the computations for us. So edit, calc, down to number 4, pick the linear because it's a line, L1 and L2. Now your job is to fill in something right here. You can skip frequency list, but go to store regression equation, store reg EQ. We need to put y1 right here. And the way to find that is using your vars key. Find the clear button, find the vars key, pick vars. You want to go over to y vars, which is the second menu. We're working with functions, so pick option number 1. And then you have the list of all the different y's that you want to put in. Okay? Right now, all of ours are blank, so it doesn't matter which one we pick. Let's pick y1, so we're all picking the same thing. And then go down to calculate. And what this will do is it'll calculate the slope for us. It'll put it into mx plus b or ax plus b format. It'll give us a couple other values called r squared and r. We'll talk about what those are in a minute. But the most powerful thing is now if you check y equals, it has automatically inserted it in for us, and if you hit graph, you'll have a perfectly linear graph going through those points. So we didn't have to do any of the computations, the calculator did it all. So we're going to pause the video right now and turn your calculator around so that you can show that you have not only the dots, but you have the line going through the dots. And if you don't, then stop and have somebody help you and show you how to do that. All right, I have pulled up another calculator, an older one, and I want to show you how that looks if you have an older model. So we're going to still do the same thing. We're going to stat. We are going to go over to calc. We're going to choose option number 4. And all we get is this plain old lin reg thing on the screen, as opposed to the other group. If you've got the newer calculators, yours looks like that. So you've got several things to put in. The older calculators have this. So you're going to have to hand type those things in. Look at what this has on it. It has L1 and L2, and then we filled in the blank. We filled in Y1 right there using our vars key. And we picked Y1. Okay, so those three things, L1, L2, and Y1. On this calculator, you've got to tell the calculator those things as well. You've got to put in L1, L2, and Y1. So pick your L1, that's down here under second, so second, L1, followed by a comma, which is above the number 7. There's a comma button. Okay, then L2, that's second L2, followed by another comma. And now you need to tell it Y1 is where you want the answer to be. So pick your vars key, go over to Y vars, pick function, pick y1, and make sure that you have those three things put in, which would be the same three things that the newer calculators need, L1, L2, and Y1. Yours just have to be put in with commas because you have an older version. Then hit enter, and you should get the same linear equation that we got before. Okay, that linear equation should be this. Okay, so, all right, what do those numbers mean? The A value is in the position of the slope. It's the same as M, so that is our slope value. The B value is the y-intercept value. And so we'll take a picture of this so that we can remember what those values are. Okay, let me get a picture. All right, so those values will help us know what our linear value is. So the linear model, we're going to round it when we write it, so we don't have room for all those decimals. So y equals 2.294, that's the slope, x, plus 2.314. Now the correlation coefficient, that is that r value, not r squared, but r value. And I want you to write 0.999. Now that's a decimal. It's got a point in front of it. That converts to the percentage 99.9%. Okay, 99.9%. That's the accuracy. That's how straight this line is. It is 99.9% accurate, which is extremely high, which is why it was a very strong correlation here. All right, the next thing we're going to do is we're going to make a table of these values. Okay, I've started the table for you down there, and we're going to fill this table in. I want you to extend that table out to 9, 10, 11, and 12. Okay. All right, let's pull up the recording. Okay, we're going to set up a table here. We want to create a new table to help us compare how close we were. Do you see how above the word window it says table set? You got to do that first. Table set. We want our table to start at 1, just like the table we were given, and we want it to go up by ones. So that'll mean it'll go 1, 2, 3, 4. It'll increase by 1 every time, and we'll have a table. So set that up first, 1 and 1, and then go to second graph to create the table. Okay. We're going to copy these numbers down onto the table that I've got for you on your worksheet. Fit as many decimals in there as you can. I know that the space is small, so as many as you can fit would be great. Okay, I've got a screenshot of that now. Let's get this out of the way. And put this down here. Okay, got a screenshot of those values. So we are looking at, let's see how good I can do here, 4.608 and 6.904, or no, 902. Okay, I'm going to pause my recording and I'm going to go ahead and fill all these in. You guys can pause the video and do the same. All right, so I've got my values filled in up to the number 8. And then what do I do with 9, 10, 11, and 12? Well, you'll notice if you scroll down on your table that your calculator extends the table for you. Let's take a look at that. Okay, you can see that I've got additional values on 9, 10, 11, and 12. And so I can extend this table as far as I need to go. We were only given 8 data points, but now we've got lots of data points because the calculator was able to generate, according to the pattern of the line, this line, if it extended, would go through those points. So go ahead and record 9, 10, 11, and 12, the data points, onto your worksheet as well. Okay, we've transferred those values, and we see that the decimal values given to us by the calculator are very close to the original data values that we had. That's because we had a 99.9% accuracy of our correlation coefficient. So these were extremely close because of the accuracy. Right? It's extremely accurate. All right, finally, we want to predict all the way out to 100. So you've got 2 choices here. You can scroll down on your table all the way down to 100. That's one way to do it. It's totally a legitimate and valuable way to do it. Okay, so you can take this, just hit the down arrow key, and just hold it until you get to 100. So that would be one way to do it. It might take you a little while, but it would work. The other way, I'm going to quit here, go to a home screen, is to use the vars key again, which is extremely powerful. You'll want to get comfortable with using this vars feature. Okay, pick your vars, go over to yvars, function, and pick y1. You should just have y1 sitting on your home screen, and put y1 of 100. That's asking the calculator to jump to 100 automatically. Hit enter, and boom, it just gives you that value. That would be the same. What the calculator is doing is it's plugging 100 into that formula. It's doing the work for you. You can either do it yourself, or you can have the calculator plug it in. So 231.7. All right, 231.7. That is the same as taking the number 100 and plugging it into the x value of the function. All right, if we did the work by hand, it would be y equals 2.294 times 100 plus 2.314. Now, if you do it by hand, you'll be slightly inaccurate because you're using rounded numbers. So that's why we like to use have the calculator do it for us, because it will give us the most accurate value. So I would really encourage you to get good at using the vars model to do any predicting of numbers that aren't on your original table. All right, you're going to want to be done with that example. We're going to try another one, and these are some numbers that we look a little familiar with what we were doing yesterday, but I want to draw your attention to a little trick. Originally, these numbers were years. Okay, it was the year 1994 all the way up to the year 2007. From this point forward, we're going to make these numbers a little bit smaller. Just makes it a little easier for us. And I actually made a typo, so I'm sorry about that. Take that 1950, and it should actually be 1900. So what we want to do is just consider the number of years since 1900. And so this 1994 is just going to be 94. And the 1995 would be 95. Okay, so let's do that together. So 94 becomes 1995 becomes 95, 96, 97, all the way 98, 99. Now be careful, the year 2000 would become 100, and then 101 would be 2001, 102, 103, 104, 105, 106, and we're going to be at 107. So we're going to use those numbers instead. So grab out your graphing calculator at this point. We're going to go now into lists 3 and 4. And so we're going to put in 94, 95, 96, 97, etc. All right, so stat, edit, go over to L3. I need to clear that because I have some old data in, so I hit clear, enter, and then I'm going to do 94, 95, all the way down. I'm going to pause the recording while I fill in the data. You go ahead and fill in the data too, and pause the recording on your end. Okay, hopefully at this point you have the data entered. So now we need to think about what window we're going to use. Remember that when we look for our minimum, we're going to look for a number that's lower than 1994. So we want to go down to the number 90, ends in 0. And then we want to do maximum. We're going to do a number that is greater than 107. So we want to go to the highest number, which would be 110. And our scale for that, remember the rule, take 110 minus 90 and then divide that by 10. So that's going to be 20 divided by 10, so our scale should be 2. And then for the other window, we want the smallest. The smaller one is negative 15.8. So we'll be using negative 20, which is lower. And then we've got 109.2. That is also 110. Okay, the difference between those two is not, it's going to be 130 over 10. So that works out to be 13 for our scale. So we'll enter that into our window. And our window is going to be 90 to 110 with a scale of 2, and then negative 20 to 110 with a scale of 13. Now don't just hit graph, check your y equals, turn off your plot 1, okay, unhighlight it, turn off your y1, unhighlight it, and then turn on your plot 2, because plot 2 is the one for list 3 and list 4. Then you can hit graph, and you should see that line. If you see any dots that are out of line, then go back and check your list, stat edit, and see if there's a dot that was actually, mistyped. But that's what it should look like. All right, we see that our correlation is negative. That doesn't mean it's bad, it just means it's going down. And it still is pretty strong. And we're going to have the calculator find the slope for us and tell us how strong this is going to actually be. We're going to repeat what we were doing previously. Okay, we're going to go to stat, and we want the calculator to find the slope. Yesterday we calculated the slope by hand, but we want to come straight down there and find the slope. So stat over to calc. We're going to go down to lin reg. Now I need to change this. I need to tell it that it's in L3, so that's second 3, and L4. I can skip the frequency list, and I want to store this regression equation, y vars, under function. I want to pick y2. What would happen if I picked y1? Well, then I would erase what I did in the last problem. I don't want you to do that. We're going to use these problems repeatedly, so don't erase it. Just put it into y2 and then calculate. This is going to tell us the slope and how accurate it is. Okay, we came up with the slope of negative 9.618, a b value of 1013.369. You can skip r squared for now, and r is negative 0.999, and then a bunch of other 9s and then a 5. So this is negative because the correlation was negative. That does not mean bad. It just means negative is going down, and the accuracy is still 99.9% accurate. So the model we have is y equals, you can copy that from your screen. We'll just round it to 3 decimals as we go. Negative 9.618x plus 1013.369. And the correlation was negative 0.999, which is approximately 99.9% again. So we're dealing with very, very good data. And we're going to practice extending our data again. Let's pick up at the kind of halfway through our data at 70.7. That matched up with the data point 98. So 98, 99, 100, 101, 102, 103, 104, 105, 106, 107. We're going to extend it to 108, 109, and 110. And we're going to have the calculator show us how accurate that table is. So if you remember how to get to table, you always have to set the table before you can go to the table. So let's set the table. We set our table with our window feature. That's second table set. We would like our table to start at 97. And we want to go up from 1 by there. So you're changing the starting value, but you're not changing the increase. And then second graph, which is table, and it will create the table for us. So there's 97, 98, 99, 100. And those are all the data points we had. 107 was our last data point. So now the calculator is able to give us 108, 109, 110, etc. So let's add those to our data. So we're adding 108, gave us negative 25.4. 109 was negative 3502. And 110 was negative 4464. And so we look at those data points. These are all very, very accurate. Okay, again, so these are extremely accurate. It's an extremely close match. Okay, finally, we would like to predict what's going to happen in the year 2015. But you got to remember, we're not actually using 2015 because we agreed that we were going to count differently. So the year 2015 is actually the number 115. So don't just think, oh, it's 2015 automatically. Make sure you remember that we changed our numbers. So one way to do it is to take the number 115 and to plug it directly in to the equation yourself. So y equals negative 9.618 times the number 115 plus 1013.369. And you can do the math yourself. However, that will be less accurate than having the calculator do it. So let's ask the calculator to do it for us. We're going to use the vars feature. So quit out of here, go to a home screen, go to vars, yvars, function, pick function number 2 this time, because that was what we're working with, and in parentheses, ask the calculator to give you 115's calculation. And that gives you negative 92.729. I guess we'll round it to that. So negative 92, stay over here. Negative 92.729 was that answer. All right, so I hope you feel more comfortable now working with your calculator to have the calculator find the slope for you, to have the calculator find the percentage of the match for you, and to use yvars to have the calculator predict values that aren't on the table, but to extend it and do future values that would come after that. All right, I will see you guys back in class on Monday morning. Have a good weekend.